This is a key to the in-class activity. In the first one, you want to solve this quadratic equation, and this is not factorable, so we're going to go ahead and use the quadratic formula. Now remember, the quadratic formula is this. It's I'm going to go and put it right here, the opposite of b plus or minus the square root of b squared minus 4ac, and all of that's being divided by 2a. Now remember that b squared minus 4ac, that radicand that you see there has a name. It's called the discriminant. So b squared minus 4ac. But this formula will give you the solutions to this quadratic equation. Now before you use this formula though, you need to make sure that this quadratic equation is in standard form. And it is. You have 0 on the other side and it's in descending order. Once you have it in standard form, which it already is in standard form, it is a very good idea to denote what A, B, and C are. So A is a coefficient of the x squared term. So x squared, the coefficient is 4. So we're going to say 4. B is a coefficient of the x to the first power term, or the first degree term. Now you got to be careful. You got to keep that sign. So that sign is a negative 12. So B is a negative 12. And C is your constant, which in this case is a positive 7. So once you find A, B, and C, you're going to substitute that into the formula. Your variable is x, so you need to say x equal because you're trying to find the solutions to this equation. So you're trying to find the solution, the value of x, that will make this equation a true statement. So x equals the opposite of b. So b in this case is a negative 12. So remember, the opposite of a negative 12, is a positive 12. So that's what I was going to put here, positive 12. Plus or minus the square root of, we're squaring b. Now remember, whenever you square b, it is never negative. So be careful. So it's always a good idea to put b in parentheses before you square it, especially if you're using your calculator. Because sometimes, because if b is negative and you don't put that in parentheses and you put that in the calculator and you square it, if you don't have parentheses, it will give you a negative number. B squared should never be negative. Alright, so I got negative b squared minus 4 times a is 4, times c, which is 7. All of that is being divided by 2 times a, and a is 4. So let's go ahead and simplify the discriminant. In this, remember in the quadratic formula, b squared minus 4ac is the discriminant. But in general, the expression that's under the radical symbol is called the radicand. So let's go ahead and simplify the radicand. So I get 12 plus or minus the square root of negative 12 times itself is 144. And a negative 4 times 4 is negative 16, and a negative 16 times 7 is a negative 112. All of that is being divided by 2 times 4, which is 8. Okay, so we're going to simplify this further, the radicand further. So you got 12 plus or minus the square root of 144 minus 112 is 32. All that divided by 8. Now remember, the discriminant is 32, right? So remember, 32 is not a perfect square. So since 32 is not a perfect square, we're going to end up with 2 irrational numbers. So not rational, because you would only get rational if the radicand was if the discriminant was a perfect square or 0. But the square root of 32, I can simplify further. You need to do that because notice it says simplify here. So the square root of 32, a perfect square that goes into 32 is 16. So I can write that as square root of 16 times the square root of 2. And the square root of 16 is 4, so I get 4 square root of 2. So that's what I'm going to put here. So I get 12, that's a 12. Let me do it over. 12 plus or minus 4 square root of 2 divided by 8. Now you want to simplify further because notice I see 12, 4, and 8. All of those numbers here, 12, 4, and 8, are all divisible by 4. So this becomes 12 divided by 4 is 3, plus or minus 4 divided by 4 is 1. 1 times the square root of 2 is the square root of 2, divided by, and then 4 divided by, 8 divided by 4 is 2. So there's your answer. So you can leave it like this. If you want to, you can split it apart. It's up to you. You can say 3 plus the square root of 2 divided by 2, and then 3 minus the square root of 2 divided by 2. Either one of those is fine. Okay? All right, now number 2, you wanted to solve the following polynomial equation by factoring. So we have 4 terms on the left-hand side, and it is in standard form. You have it written in descending order: x cubed, x squared, x, and 5. The constant, rather, is equal to 0. I'm going to go ahead and rewrite this over so you can see the exponents a little bit better. And remember, when factoring a polynomial with 4 terms, you want to try grouping. Remember that? Try grouping. So we're going to group the first 2 and then the last 2 and see what happens. In the first group, if you look at the first group, the GCF of that first group is x squared. So I get x squared times, I can factor out that GCF, which is x squared. So I get x squared times 3x, because x squared times 3x is 3x squared, minus, and then x squared times a negative 1 is a negative x squared. Okay? Now in that second group, so I get this right here. So this is this. So if you were asked to just factor this polynomial right here, this expression, this is what you would write. Okay? But over here, when I factor this, I'm going to go ahead and factor out a negative factor. So I'm going to say minus, and then both of those terms have 5 in common as the GCF. So I'm going to factor out a negative 5 times, and then negative 5 times 3x is a negative 15x, and a negative 5 times a negative 1 is a positive 5. And don't forget to say equals 0. Now, if you're doing this correctly, if this is factorable by grouping, those two expressions here will be the same. But remember, you want to factor this, so you gotta show me that it's factored first. So to factor it, remember, factoring means to write this as a product. So write factors as a product. So when I take out the 3x minus 1, when I factor out the 3x minus 1 from both of these parts here, notice what happens. I'm going to get x squared. And then over here, when I factor out that 3x minus 1, I'm left with negative 5. Okay, equals 0. So I factored this, so this right here can be factored as 3x minus 1 times x squared minus 5. Now remember, I'm trying to solve for x, right? I'm trying to solve for the variable here. So I got to get x by itself. At this point, I notice that I have 2 factors whose product is 0. So one of those factors has to be 0. So either 3x minus 1 is equal to 0, or x squared minus 5 is equal to 0. I got to find all the possibilities. So this is linear. That's easy to solve for. So when I solve for x, I get 3x equal 1. So x is 1/3. Okay? Over here, this is a quadratic equation, but I want you to notice that this is easy to solve because there's no x to the first term. So the linear term is missing. I have the second degree term, and I have the constant, but I don't have that linear term. So that means that I can solve this using the square root property. So when I rewrite this, I get x squared equal a positive 5. And at this point, I'm going to take the square root of both sides. Don't forget, when you do that, you get plus or minus, though. And so the square and the square root undo each other. So you get x equal plus or minus the square root of 5. And the square root of 5 cannot be simplified. So if you want to write your solutions using commas, you would say x equal 1/3, comma, square root of 5, comma, negative square root of 5. So there are 3 solutions: 1/3, square root of 5, and negative square root of 5. Okay, but either one of these is fine, either this or you can say this. All right, so that is the key to the in-class activity.